Welcome. We're now ready to take a look at 5 cases of finding probabilities involving a binomial random variable. So let's jump in with this example. A new surgery is successful 72% of the time. The results of 6 such surgeries were randomly sampled. So let's talk about this binomial experiment. So we have 6 as the number of trials, and then 2 possible outcomes, success and failure. So lowercase p there, the probability a surgery is successful is 72% or 0.72. And Q then would be the probability a surgery is a failure. So Q is the complement of P. So Q is 1 minus P. So 1 minus 0.72, that will be 0.28. So a 72% chance a surgery is successful. That would be a 28% chance it's not successful. All right, we don't need Q right now, but we will come back to Q in a bit. So let's go to our probabilities, where our random variable X is the number of successful surgeries among the 6 that were sampled. All right, so we're going to find the probability exactly 3 surgeries were successful. So I wrote the possible values of X here. So it'd be possible none of the 6 were successful, or exactly 1 was successful, or 2, etc. And we're looking for 3. So I'm just going to circle that one. So in the exact case, this is the probability that our variable X is equal to that value, 3. And we're just using K here to represent whatever that number is in our problem. So that value is our K, just to have some formulas you can reference there. So in the exact case, this is when we do our binomial PDF. And we enter the N, the P, and then that value, in this case, K of 3. All right, so in my graphical display here of my probability distribution, we'd be finding the probability or the area. We'll use area and probability interchangeably, the area of just this single bar. So we'll go to our distributions and binomial PDF for the exact case, and then 6, 0.72, 3 out of the 6 successes. And I'm going to round to 3 decimal places, so 0.164, so 0.164. And just so I can speak it here, I'll do it as a percent as well. There's a 16.4% chance that exactly 3 surgeries were successful. So if we were to add all of the areas of these bars together, it would be 100%, and that particular single one is 16.4%. Okay, so let's take a look at B here. What is the probability at most 3 surgeries were successful? So at most 3 means 3 at the maximum. So 3 of them, or 2 of them, or 1 of them, or none of them. So in this case, probability that X is less than or equal to 3. All right, so rather than finding the binomial PDF of each one separately and adding them ourselves, we have this function on the calculator, binomial CDF, which will add those probabilities for us. So N, P, and K. So again, that value in the problem K, that's what we're writing there, and then we're just ending there with that value as the third in the entry into your binomial CDF. All right, so back to our distributions. And then make sure you pick CDF, 6.723. And 3 decimal places will be 0.220. So 0.220 as a percent, 22.0% chance that most 3 were successful. So that would be the areas of those 3 bars together. All right, so those are our 2 cases that we've considered so far. And now we're going to go on to the last 3 cases. I'll come up and fill in this table for you in a bit, but let's talk about the cases here. So I'm going to just point out in the Binomcdf and CDF cases so far, the value in the problem, exactly 3, the 3 went in that position. And at most 3, the 3 was in that 3rd position. And those are our 2 functions available to us. So now let's take a look at C. How about the probability that less than 5 surgeries were successful? So the probability that X is less than 5. So less than 5 would be 4 or 3 of them, or 2 or 1 or none. Okay. So I know I'd like to add probabilities together ending at 4. So less than 5 is equivalent to saying X is less than or equal to 4. So once we can write a question with a less than or equal to, then we can use our binomial CDF to add those probabilities together for us. So none successful, 1 or 2 or 3 or 4. All right, so in this case, 6.72, and then we stop at 4. So the thing we want to be careful with here for the less than case, so the number they give you in the problem, less than 5, so that's less than that value, 5. But when we get to our binomial CDF, we don't put a 5 here because less than 5 would end at 4. So if you want to think of it as a formula, less than K, that number is right before K. So that would be K minus 1. All right, so let us go back to our distributions here. So binomial CDF, 6.72, comma 4. That's 0.536. All right, so there's a 53.6% chance that less than 5 surgeries were successful. So those bars right there. All right, so that's how we handle less than. And then we've got 2 more cases here. Now, the last 2 cases both require the rule of complements. So just a little reminder over here, the rule of complements. So if we want to find the probability of an event happening, it will be 1 minus the probability that an event does not occur. All right, that's a little hard to read there. The probability that an event does not occur, the complement. All right, so let's take a look at this one. The probability that more than 3 of these surgeries were successful. So the question is, the probability X is more than 3. So more than 3 would be 4 or 5 or 6. Now, if I were to add all of the probabilities together, I would have to get 1 or 100%. So in other words, if we added the areas of all the bars, we have to get 100% or 1. So if I would like to know the probability of 4, 5, or 6, I know that the complement of that, everything other than 4, 5, 6, would be 0, 1, 2, 3. So if I can find the complement of this event, then we know that 1 minus the complement probability will give us the answer. So the complement is that x is less than or equal to 3. So as soon as we have something written as less than or equal to, we can use binomial CDF, because binomial CDF will add these probabilities for us. So the complement will be binomial CDF NP, and the complement ends at 3. All right, so in this case, the question is more than 3. So there's your K, more than 3. And then we just have to remember that you have to do the rule of complements. So to get the probability of the event, 1 minus the complement, and that complement ends at that same value that was in the question, that K. So on the calculator, I'm going to enter it just like I highlighted it there, 1 minus, and I go to my distributions, binomial CDF 6.723. All right, and that's 0.780. So 0.780, or 78.0% chance that more than 3 were successful. Okay, one more case. At least 3 were successful. So that question would be the probability that x is at least 3 is 3 or more. So 3 or 4 or 5 or 6. All right, so we're going to do our rule of complements in this case. So it will be 1 minus the probability that x is less than or equal to 2. Okay, so hopefully by circling the event, it's easy to see where the complement ends. So in this case, it's 1 minus binomial CDF. So the N, the P, and now we're putting in 2 where the complement ends. So the thing we want to notice here is that if it's at least K, 3, so that's the K. Then when we use our rule of complements, you're not putting in that 3 here. This will always be the number before that value of K. So now again, we're going back to this K minus 1. Okay, so 1 minus binomial CDF NP, and K minus 1 is 2. And that's 0.944. Or 94.4% chance. All right, so it's rule of complements for the at least case and the more than case. So let me summarize that up top for you so you kind of have a little bit of a template here to follow for these cases. All right, so we know what to do with exact. That's when you do binomial PDF. And then the at most, or K or fewer, that's your binomial CDF. And then for the remaining cases, we use rewriting into a form involving this case to get our answers. All right, so if it was X less than K, so fewer than K, then we could do binomial CDF, the N and the P. But in the less than K case, like less than 5, the binomial CDF ended at the number before k. So k minus 1. And then these last two cases involved the rule of complements. So the greater and the greater than or equal to cases. So if the question is more than k, so it's going to be 1 minus binomial CDF NP and then for more than k, the complement ended at k. So one more time down here. So for more than 3, 4, 5, 6, the complement ended at that value of k. So k. But in the at least case, the complement, so 1 minus binomial CDF, in the at least k case, the complement ends at k minus 1. All right. So that table at the top will give you a template to follow for the 5 different cases of finding probability.